morning students. Today we are going to discuss about the electric potential due to a point charge. In previous class we have discussed what is electric potential. How we will define the electric potential at a point? If there is a presence of electric field and if you are bringing a unit charge from infinity to that point, then at that point we will get the electric potential. So electric potential at a point is the work done in bringing a unit positive charge from infinity to that point. So for deriving the electric potential expression, first we will find out what is the work done in bringing a charged particle from one point to another point, and then we will integrate and give the limit from infinity to that point. So let us derive. If the source charge is plus q and suppose it is placed at a point O, and there is another charge. Which charge? No, since we are finding electric potential at a point, so we will take a unit positive charge, that is suppose plus 1 coulomb, and it is placed at a distance of r dash, and the charge is suppose at point P dash. If I will bring this charge particle from here to here, if I am bringing this charge particle from here to here, then what is the work done? And after that we will limit the work done from infinity to a particular point. So first, what is, since this is a plus q charge and here we are having plus 1 coulomb, first we will write what is the electrostatic force. The electrostatic force expression, as we know, F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. Here Q1 is capital Q and Q2 is 1 coulomb. So into 1, and what is the distance? Distance is R dash square. So this is the electrostatic force. And as it is a vector quantity, I am giving its direction also, that is towards this. Then we will go for work done expression. Del W. Since we are taking the displacement for a small displacement, suppose the displacement is del R dash. So we are bringing the charge particle from here to here, that is a displacement of del R dash. So for small displacement, what is the small work done? Now work done is equals to force into displacement. So force into the displacement. See here the electrostatic force positive, this one is also positive. So it will experience a repulsive force towards east. But we are bringing the charge particle towards left. So these two vector will have opposite direction. So what we will get here now, F del R cos 180 degree. So minus F del R, sorry dash, del R dash. So minus, what is the expression of F? No, 1 by 4 pi epsilon naught Q by R dash square into del R dash. Next, we will find out what is the total work done. First, we have found what is the work done in bringing from here to here, from for small displacement. Now, our aim to find out the work done in bringing the unit charge from infinity to that point, which will give us the electric potential at a point. So, suppose we want to bring this charge particle from here to a point, suppose P. So, what I will write? So, what is the work done? This one is your total work done. So, the total work done W is equals to integration of this del W. And what is the limit? The limit will be from infinity to, suppose this point is at a distance of R from point Q. So, infinity to a distance of R. So, the limit will be infinity to R. That means we want to find out the potential at point P. So, infinity to R, and this one is your minus 1 by 4 pi epsilon naught Q by R dash square into dr dash. Since this one is a constant term, I will bring this out. Minus 1 by 4 pi epsilon naught Q, then integration from infinity to R over 1 by R dash square dr dash. So, what is the integration of 1 by x square into dx? Its integration value will be minus 1 by x. So, now I will write this as minus 1 by 4 pi epsilon naught Q. Let me write Q here. Q. What is the integration of 1 by R dash square dr? If I will write 1 by R dash square dr dash, then it obviously it will give me minus 1 by R dash. So, in this place I will write minus 1 by R dash from infinity to R. So, now let me write this one. Our work done is minus Q by 4 pi epsilon naught. This minus becomes plus, and let us put the limit. First, upper limit as 1 by R minus 1 by infinity. So, this becomes equals to 0. So, now the work done in bringing a positive unit charge from infinity to this point comes to be Q by 4 pi epsilon naught R. So, the work done in bringing the unit charge from infinity to that point becomes the electric potential. So, this is the expression of electric potential due to a point charge. So, V is equals to 1 by 4 pi epsilon naught Q by R. If suppose we have been asked to find out the electric potential at a point due to multiple charges, due to the presence of multiple charges, then what will be the answer? No, the electric potential at a point due to multiple charges is the algebraic sum of all the potentials at that point. That means if we are having here a point P and we have to find out the electric potential due to number of charges. Suppose this is this one Q1, Q2, Q3 and Q4, and they are at a distance of R1, R2, R3 and R4. So what is the electric potential at point P? So electric potential at point P is defined as the sum of electric potential due to all the charges. That means I will write potential due to charge 1, that is V1, plus potential due to charge 2, V2, plus V3 plus V4. So what is V1? Now Q by 4 pi epsilon naught R1. So Q by 4 pi epsilon naught R1 plus Q by 4 pi epsilon naught R2, like this. So what is the difference between your electric field intensity and potential? In case of electric field intensity due to multiple charges, we are saying that is the vector sum of electric field intensity due to all the charges, whereas in case of electric potential it is simply the algebraic sum of all the potentials due to all the charges. So this is your expression for electric potential. Next class we will discuss the electric potential due to a dipole. So go through it and thank you.